Hello and welcome back to the channel. In part 2 of the fixture plate build series for my open build C-beam, we're going to go over the motion plate that connects the lead screw to the rails on the Y-axis. This is the design right here. I showed it a little bit in the first video, but we're going to go more in depth into this one. So on this fixture plate, there's, I think it's 16, it would be 16 3mm holes with a 6mm counter bore. There's this little pocket here and two 5mm holes. Those hook into the actual lead screw nut. And then I have 4 through holes that are 1/4 inch and this little pocket that's a 1/4 inch. And what those are for is those are for little pins that are machine ground. And they're basically going to use as alignment pins for the main fixture plate on top. But that's just there for alignment so that when I do bolt in the 4 3/8 hole bolts, that everything is nice and square and I have repeatability. So if I take this fixture plate off, like if I have to do maintenance or something, I'm able to stick it back on and it's going to be squared and I don't have to worry about having to retram it every time. And that's really about it for this. This is a 3/8 inch thick piece of aluminum. I'm cutting it from a 1/2 inch thick stock, and in a moment I'll show you the cam. Alright, now that we're in the cam space, I'm going to go over the 10 operations that are going to be used to complete this part. Now off screen I already flattened the bottom side, so I'm not going to have to flip the part over. I just figured since my mill is able to do basic surfacing operations built in without having to make any G-code on Fusion, I just wanted to do that. That way, one setup and I can do all 10 operations. So the first operation, we're just going to do a basic decking of the top side. When I was looking at the plate, it did have a little bit of a bow in it on my stock, so I already planned for that when I sized it. So I got 1/2 inch stock as opposed to 3/8 because I knew there's going to be. It's always going to have a bow. I mean, that's just how bar stock is. So I already decked off 2mm off the bottom, and then the final millimeter will get decked off the top here, and then we'll have a nice flat surface. Then the next operation is I'm doing a 2D contour, or a pocket rather, of the inner pocket where the 5mm screws hold into the lead screw plate. And then I'm just doing a little plunge cut with the end mill just to make that flat pocket there. The next operation is I'm pilot drilling all of the larger holes. So it's an 1/8 inch drill that's going to make holes for all the 5/16 holes and all the 1/4 inch holes. And that's just so that, remember on the video that I showed last week, the drilling operations work really well if you just do an 1/8 inch pilot hole so that the chisel doesn't grind into the metal, and it just provides a lot better chip control and I don't get any chatter. The next operation is just drilling out those 5/16 holes. Then after that I'm drilling out the 5mm holes. Then I'm doing the 1/4 inch, and then I have 16 3mm holes I'm drilling. And in the second of 3 actual milling operations, I am drilling out the counter bores for the 3mm holes. That's just so the cap screws have somewhere to sit and be underneath the surface of the plate. And then the final operation is I'm doing an outside contour of the entire part, and I'm going to add some tabs just so that it doesn't shift around while I'm doing the final cuts. I'm going to be holding this down with blue painter's tape and super glue. It does good on large surface area parts like this. It's just I sometimes feel a little more safe if I just have tabs on there, in case that way you got even more surface area after it's been cut free. And it's really easy. You just take some wire cutters and you just cut the tabs, and then you just belt sand the little tabs areas flat, and you're good to go. Next we're going to go over some of the drill contour stuff just so that you can see all of the information for the actual operations. Alright, let's go into the operations. The 2D face cut, that's pretty self-explanatory. I'm just using my 1 inch 3 fluid insert end mill face cutter. I'm running at 8,000 RPMs. It's going to be doing a 200 millimeter a minute feed rate on the surface. And yeah, it just basically chugs along. It's going to take about an hour supposedly to do this. I'm going to probably tweak the settings a bit because when I'm doing the facing operation on the control itself, it takes 10 minutes. So I'm going to tweak this some more between now and when I actually cut the metal. Geometry, Fusion has this option where you can actually just select the stock itself. If you just leave this empty, it decks the whole stock, which is nice because if you actually select the contour of the part, you'll end up with a little lip where you don't have part but you have excess stock. And when we come to do the contour cutout of the part, you'll end up with a couple millimeter height difference on the back side, and you don't want that because then your end mill is going to be cutting more than you want to cut. Heights, just standard heights. Passes, I do 2 passes. And then linking, I don't really work with this much because it's just nothing I really worry about because I'm not doing multiple parts on that tool. The 2D pocket is pretty simple. It's just a 1/4 inch flat end mill, 2 flute. I set to 500 feed rate. Works pretty good. You just select the inside contour. And then the heights, same deal. Passes, I'm doing multiple steps at 0.3 millimeters a step. That just seems to work well for this size cutter. The next operation is a drill. This is the only one I'm using an end mill for drilling, so it's just pretty easy. I'm only going down, I think it's 2 millimeters, so it's not too big of a deal. It just plows down, pulls up, and you're done. The next tool is I'm using an 1/8 inch drill to pre-drill all the holes. I'm using the deep drilling operation. I mean, I don't really need to. I could just use the chip breaker. But this is a small end mill, or not end mill rather, but drill bit. So I want to have a full retract so that my coolant can actually get into the hole and keep everything nice and lubricated. So it's basically, actually I need to change that. That should be 8,000 RPM. 16,000 would be a bad idea. There we go. And then got the 8 holes. Now to select the holes for the next operation, I'll show you a little trick I did. And then height, same deal. And then deep drilling, I'm doing 0.5 millimeter pecks. And all these drilling operations are really quick. They're less than a minute per operation, which is really nice because if I were to try to like actually bore these with a mill, I would take hours. And then that's just the same deal, but with the 5/16 bit. Same deal with the 5 millimeter, and then the 1/4. Now for these 3 millimeters, I had to do something a little different. So as you can see, when I did the selection, I selected right here, but that's dangerous because when you have your heights tab here, originally the top height was the top of the hole. Well, that top of the hole is 1/4 inch down into the material, and if I were to just leave that the way it was, I'd be crashing my drill bit right into the side of the part, and that would be bad. So what I did is I switched the top to the top of the stock, and then it drills down from there. So yeah, I'm drilling a little bit of air at first, but I'd rather have that than drag a drill bit across the stock and break it. So that was about the only trick I had to do on that one. And then the contours, this is the second of 3, and it's literally the same as this pocket with a 1/8 inch end mill. It just goes in, cleans out those pockets to 6 millimeter diameter. If they're not perfectly circular, I do have a counterbore drill bit. I can use my drill press to clean them up if not needed, but I've done this before and it hasn't really been an issue before. And then the final one is an outside contour, and for that contour I am having tabs put on it, as I mentioned earlier, And to do that, all you do is you just click the little tab button. I prefer triangular tabs over square tabs because it keeps your momentum going on your milling. So what happens if you do a square tab is it drives over, it stops, it goes up, it drives over, it goes down, and that's pretty violent for a C-beam type device. Maybe for a proper rigid mill it'd be okay, but for this purpose it keeps the momentum going, it holds them really good, and to be honest, it's actually easier to remove these tabs than the square ones as well, so get a little extra bonus on that as well. And then same deal for the multi passes. I'm doing 0.5 millimeter passes on this one, and that's really about it. And they'll clear it out, and that operation is actually pretty long. That operation right there is actually longer than the rest of the other 9 combined. So that one's a 20-minute. The rest are 12 for the counterbore pocket contours, and then the rest are a minute or less just because they're drilling. Now what I could do is I could get a 6mm flat bottom end mill and just drive down there with a drilling operation, but I don't have a 6mm end mill, so I'm not. I guess I could use a 1/4 inch, but the idea is to try to keep those pockets as tight as possible for alignment of the little MGN12 trucks. And that's about it for this part. I might add a chamfer to this after the fact. I haven't decided yet. If I do, I will let you know. But most likely what I'll do is I'll just clean it up with my Noga tool and be done with it. This part's not going to be seen once it's attached with the fixture plate, so sharp edges aren't really a concern. I'm also going to be doing another deck off of this once it's installed onto the y-axis, just to tram it in, because it's easier just to deck this off than it is to try to bend the actual machine itself. So once this is all decked to the machine, it'll be perfectly flat in all directions to that machine, and you won't have to worry about any variances in heights. I don't really have that problem right now, but it just makes it easier. Alright, and now we're going to get to some setups and some machining. So as you can see in this clip, I had a little bit of an oopsie. What I had done is I had forgotten to change the heights in Fusion from stock top to model top, and so it did not realize there was material there when I made this cut, and it actually plunged down about 4 millimeters, and it caused all kinds of problems. Luckily I was able to recover the part. There's a few blemishes. This is one area that was a blemish, and there was one area when I was actually cutting the part out that I'll show you in a bit. But yeah, when you're in your cam suite, make sure you have your heights proper, or else this will happen. And this is what it looks like with it being fixed. As you can see, there was some damage on the right and left side. In the final part, you'll see that other than just visually it doesn't look nice, it didn't really affect the part any. And this is me after I corrected it and finished that feature of the part. Unfortunately, my GoPro failed when I was doing the contour to cut the part out of the stock. It did have an issue. Apparently, the work holding I had got too saturated with WD-40, and what happened is the tape started to pull up a little bit when I was doing the tabs, and on the very last pass it actually shifted, and that's why you can see that bite out of the bottom right corner of the part. And then you can also see the little side step on the inset feature in the middle of the part. That's where it was. Here I was tapping the 316, actually rather 3/8 tap. Those were not fun. I'm glad I only had to do 4 of them. And then in the next picture, it is the final part. This is what it looks like. Obviously not installed, but it's got the 4 3/8 cap screws, and then I also got in this picture I only have 4 of them, but there's gonna be 5 in the center divot. I ended up just drilling that out since it wasn't very deep, and I needed to get better engagement with the center pin, and there's also a center pin that goes there. So this is the finished part. thanks for watching. If you liked it, please subscribe, and next video we should be starting to tackle the main fixture plate. That one's going to be a bear. I might have to break that one into a couple parts since it's going to have a lot of setups, and I'm still not quite sure how I'm going to actually machine that in my little mill. I might have to do a lot of finagling around and resetups, and we'll find out next video. And have a good one, and see you next week.